welcome back to the morning show. We are with Jesse Miller this morning, part 2 of our segment on water. Hey, Drew, come on in.
Hey, thanks, guys.
We decided we'll let him join this morning. Okay, so Jesse, as it pertains to water, I heard that if you spray your windshield with like a mixture of vinegar and water, I think it is, that it'll stop it from creating that frost you have to scrape off in the morning. Is that true?
Yes and no. It's true in the sense, it depends on the temperature. Let's put it that way.
Okay.
Okay, now normal frost activity, which it can frost before it gets below freezing, right?
Sure.
That would certainly work for that, because what the vinegar in there does is it lowers the freezing point of the water. Okay, so you could put salt water on there. The problem is salt water, you're going to leave a film.
Right.
So vinegar tends to not. It'll evaporate and you won't have that film on there.
Okay.
It'll go off with the water. So yeah, anything that you put in there, whether it's vinegar or some kind of soap solution or something like that, will stop that, or at least lower the freezing point enough to where it won't frost up.
Okay.
So and it'll coat what you're trying to do is coat the windshield with something other than just plain water.
Sure.
And if you do that, then then it's not going to frost up to a certain point. Like, this morning, I don't know what the temperature was, but it was probably in the low 20s, right?
Yeah.
I don't know how much you're going to lower the temperature with vinegar. I do know with salt, as a matter of fact, we'll probably, once we start salting the roads and stuff, I'll do a segment on how we lower the temperature of the freezing point with salt. But yeah, it's a basic principle. You put anything in water, you're going to lower the freezing point of it.
Huh.
In this case, vinegar works nice because it doesn't leave a film on your windshield. So you'll just use your windshield wipers so you want to go out and
try
spray
my own
your
little
windshield.
science experiment.
That's right. Now it's probably good up until 20 degrees. I'm guessing. But certainly for these nights where it's just really clear and it doesn't necessarily get down below freezing, but you still have frost.
Yeah.
Because what ends up happening is you're radiating heat faster than the air temperature can bring it back in, because outer space is pretty much a complete heat sink. So if you don't have any clouds to keep the heat in, you're just radiating heat out, and so that water condenses onto your windshield and then freezes. So that's how you can get a frost when it's still above freezing. Okay. And that would certainly stop that. Now, once it gets below freezing, it just depends on how concentrated, the solution you make is.
All right. Well, enough about my problem scraping off the car in the morning.
Well, it's cool.
You got something boiling over here.
It's a nice segue, because water, as I said, you lower the freezing point by putting stuff in it. You can also lower the freezing point and raise the boiling point with, if you put salt in water, you'll raise the boiling temperature. Okay, they call these colligative properties of water, but you'll raise the boiling temperature of water. Also, the pressure affects it. So I don't know if you ever heard that people that live in the mountains, if you're boiling something, you have to cook it longer, right? And why is that? Well, it's because the boiling temperature of water is lower in a lower pressure than it is here down. We're pretty close to sea level. Close enough to where the atmospheric pressure is not that much different. So I've been boiling some water just to get it hot, and if we set this out, it'll cool down enough to where it'll stop boiling, I hope, because otherwise it won't be nearly as spectacular. And I have a vacuum pump here, and what we're going to do is we're going to draw a vacuum on our water, and it should start boiling again. Okay, so I'm just waiting for it to stop boiling. I should have taken it off just a little bit sooner. All right, there we go. We're stopped boiling now. I'm going to turn on my vacuum pump. We'll put a stopper in here, and there you can see.
Oh, wow.
The water starts boiling all over again.
And it's just because you lowered.
It's because we lowered the pressure, and the vapor pressure of water is what it is at certain temperatures. And when you lower the pressure outside, more of the water escapes that equilibrium. Okay, you want, nature abhors a vacuum, right? So it wants to fill that void. So more of the water escapes and it boils. Okay, the temperature is actually less than boiling right now at atmospheric. But once again, if we lower if we draw a vacuum on it, it's boiling again. Doesn't raise the temperature. It's just turning to a gas at a lower temperature. And I have another experiment if we have time. Do we have time?
I think quickly we do.
I think so.
Okay, this is not going to be quick. So
Fantastic.
The other way we could do this is, and what I was going to do, and it's pretty good that I didn't do this. I burnt myself really bad last night, so setting this up.
Don't try this at home.
That's right. What we do is, it's easier to do in a lab than it is here. Nothing's going to explode. I'm not going to do anything. All right, so we heat this round bottom flask, and then put a cap in and turn it over, and then I can take this bag of ice and put it over the top of it, and it'll start boiling again.
How long is that going to take?
It's longer than we need to
More than 20 seconds.
More than 20 seconds. So you put this bag on there, and it'll start boiling again. And the reason for that is, even though you're cooling down the top, this void, when you turn this upside down, there'll be a void space on the top. And if you cool that down, it draws a vacuum. And now you've lowered the pressure, and it starts to boil again just like it did over here. It's just a little bit more dramatic way to do it. But it shows the same principle that if you lower the pressure, the water will boil at a lower temperature.
Okay.
So,
cool stuff.
It's kind of fun, but maybe I'll do it again some other time when we're not discussing other things like windshields.
All right, Jesse, thanks so much for joining us this morning. We appreciate it. We'll have these segments online right after the morning show. We'll be right back.